Hey guys, welcome back to the second part of congruency. This will be the last assignment that we do before Thanksgiving break, so I hope you guys are excited about Thanksgiving break. Also, if you are behind on any of the assignments or you have incomplete assignments, let's go ahead and get those turned in, resubmit those for full credit, so that in the case that we end up not being able to go back to school and I have to base your grades more based on homework instead of your test, your grades will be a lot higher in the class if we end up doing that. So go ahead and use this time. We only have 5 assignments, I believe, with this unit, which is not very much at all. And so we should be able to get, you should have plenty of time, about 4 weeks or so before the end of the semester in order to get all of your homework turned in. So even if you're pretty far behind, just start working on that and let's get caught up. That can make your grade go up by quite a bit. All right, so we're going to now, we talked about congruent figures. So we talked about when all 3 angles or all 3 sides of triangles are congruent. That means that then they would be congruent triangles. Well, now we're going to be able to prove congruency based on just having 3 pieces of information, like side, 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 or the side included angle and side. So before, we have to actually know what it means to be an included side and included angle. So what angle is included in between the sides CD and AC, which are the 2 red lines here? Well, the angle that's included directly in between those is going to be angle C. And we can't just call it angle C because we don't know if we're talking about ACB or ACD in that case. So we want to refer to it with 3 points as angle ACD. So what angle is included between the blue sides here, BA and AD? That's going to be angle A, or better said, we're going to call it angle BAD or angle DAB. Either way will work. About included sides in this case between the 2 angles. So between angle B and angle A, so B and A are here, so side BA is going to be in between those 2. Now the reason we're going to do this is because we're going to be proving triangles congruent by angle side angle. And so whenever we do angle side angle congruency postulate, the side has to be included directly in between the 2 angles. So here we have our angle, we have our other angle, and directly in between those 2, included in between the angles, is this side right here. Okay, so this would be angle side angle. Same thing here. We have this angle and this angle. The side that's included in between it is going to be the side CD. So CD is included in between angle C and angle D. It would be CD, and this would be AB. All right, so here's an example here. Can we prove that these 2 triangles are congruent? They look like they're congruent, but can we prove that all the sides and all the angles are congruent? Well, first of all, we notice that we have 2 sides here that are the same. These 2 sides are the same as well. And then AC is going to be reflexive and congruent to itself. Remember the creepy baby photo? So things are congruent to themselves. So this length AC is going to be the exact same length for the triangle on the right as it is the same length for the triangle on the left. So therefore, it's congruent to itself because AC is congruent to AC by the reflexive property. So we know all 3 sides here have to be congruent, right? This side is congruent to that one, this side, the 2 goes with the 2, and the 3 goes with the 3. So because these 2 triangles have the same 3 side lengths, we can say that they are indeed congruent, and we can write a congruency statement. And we're going to say they're congruent by side, side, side congruency postulate, triangle congruency postulate. So ABC, we have to line these up with the corresponding parts. So A goes with A, okay, so that's pretty simple. Then the angle B over here, that's the angle between the 1 and the 2 side. So between the 1 and the 2 side, clearly is going to be D, in case you're curious. And then C is going to be this angle between the 3 and the 2. So between the 3 and the 2 is still going to be the angle C as well. Okay, so triangle ABC is going to be congruent to triangle ADC. Now there's other ways you could do it. We could do ACB and ACD. We could also do CAB and CAD, etc., etc. Just as long as you match up the red with the red, the green with the green, the blue with the blue, right? All the corresponding angles and sides and parts all have to be matching up like we did yesterday. All right, here we have this triangle here and this triangle over here. Notice they have a side that's the same. This angle is the same as that angle, and this side is the same as that side. So this would be side angle side congruency. So we have side, included angle, and side. So this is by side angle side, where the important part is the location of the angle is included directly in between these 2 sides. The same thing here, we have the same side, right, 1 and 1, the same included angle, and the same side here, 2 and 2. Okay, now they're switched, or you know what I'm saying, they're flipped, but they're still the same side included angle and side included angle side. So this is by side angle side, and the angle is included directly in between those 2. Okay, so they are going to be congruent by side angle side triangle congruency postulate. And let's finish our congruency statement. So E is going to be the one that's on the end, the other side of the angle and 1. So on the other side of the angle and 1 is going to be N. So E corresponds with the N. So we'll start out here. Okay. D is the angle that was given, which is O is the angle that was given over here. So those two match up. And then F is the only one left over. So that's going to have to be going with P. So NOP. So triangle EDF is congruent to triangle NOP would be our congruency statement. Our example 3, so we see two sides that are exactly the same. We don't know about the third side, okay, so we don't just assume that those are the same, but we do know something about these angles in the middle. So the angles in the middle are going to be vertical angles, right? They're opposites of the intersection of those two lines, so they have to be congruent to each other. So we can go ahead and mark those angles as congruent because of vertical angles. So now we have enough information to prove these two triangles are congruent by side angle side. Actually, let me change the color. Probably be a good idea. So side angle side congruency postulate. So the same side here, the same included angle, and then the same side as we had here. So side angle side. So these are going to be congruent by side angle side, where the angle is included directly in between the two congruent sides. Okay, cool. So let's write a congruency statement on this one. So we have ABC. So A is the green one, or the blue one. Wow. It's the red one. That's on the other side of the angle and the side 1. So the one side and the angle would be E. Okay, so A, B, C is going to go with E, B, and then of course D. So E, B, and D. All right, let's do another one. So that's it. So right on into the assignment. Number 1. Side, side, side postulate. Go ahead and read this. If all three corresponding sides of two triangles are congruent, then the triangles are congruent by side, side, side. Write the corresponding sides of triangle JKL. So we have all the sides listed out over here. So JK is going to be right up here. That's going to be the side length of 1. So that's going to go with the side length down here of 1. So Y and X. Now I want to go ahead and write these in the same order. In fact, I might even start out with a congruency statement. That might be the easiest way to do it. So J is going to correspond. J is between the 1 and the 3. So that's going to go between the 1 and the 3, which is X. So J goes with X. Okay. K is between the 1 and the 2 side. 1 and 2 side would be Y. So X, Y, and of course Z has to be the last one. So then based off the congruency statement, I can actually finish these and they'll be in the same order. So JK, first 2, is going to go with XY, the first 2. Okay. And then KL, last 2, goes with YZ, the last 2. And then JL, first and last, goes with XZ, first and last. Okay, so kind of a trick there. Write the congruency statement first, then you can pick all the corresponding parts out from the congruency statement. All right, number 9, are the triangles congruent? If so, write the congruency statement and the postulate used to prove them congruent, side, 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 or side, angle, side. There are other postulates that we're going to get into when we come back from Thanksgiving. In fact, there's 3 more. But don't worry about that too much. If there's not enough information to prove the triangle's congruent by side, 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 or side, angle, side, then just write no. So again, the only ones that we're using are side, 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 and side, angle, side. Okay, we don't know about any of the other ones yet. All right, so on this one, we have an angle, a side, and a side. We have an angle, a side, and a side. So this one is not going to be side, angle, side because the angle's not, if you notice, it's not included directly in between the two sides. That would be this angle right here, right? So if I was told that J and F were congruent angles, then I could do side included angle side, right? Side included angle side. But that's not what I've been given, okay? So it's not side angle side. If we look at what we have here, we actually have an angle and then a side and another side. So this is actually what we call the donkey postulate. I like to write it as a money sign, money sign. Yes, I know it's controversial. That's how you'll never forget it. You can ask all my students from previous years. I've always done it this way. I have no idea what the money signs mean. It's clearly not the A word. I see this word all the time in like, I don't know, titles of explicit songs or whatever, but clearly it doesn't mean what you think it means. It means something completely different. I mean, I don't know what it means because, you know, I don't listen to explicit music. But anyway, we call it the donkey postulate, okay? And by the way, we can't use the donkey postulate. It's not an actual postulate, so that does not work. I'll write it again for you, just in case you're curious. Yeah, don't use that word and don't use the donkey postulate. It doesn't work. It's actually ambiguous, and I'll show you why it doesn't work later. So anyway, we do have angle, side, and side, money sign, a money sign, money sign. It does not work. So our answer, we're just going to simply say, no, they're not congruent. We don't have enough information. All right, on number 10, on this one we have a side, I want to fix that because I'm OCD, and side, and then the angles are the same, and then EF is going to be congruent to itself. Again, that's by the reflexive property. So EF is congruent to EF by the reflexive property, if you want to go ahead and fill that part in there. It's kind of scaffolding the whole thing for you. So on this one, we have a side, an included angle, and a side, the same side, the same included angle, and the same side. So this would be side, side, where the angle is included in between those two. Okay. All right, number 11. All right, on this one, we have two sides that are the same. We also know that KO is congruent to KO, right, by the reflexive property. So we have all three sides are congruent. So we can prove congruency on this one by side, side, side. Pretty easy. All right, number 18. AC is congruent to QS, so I'm going to mark it. Okay. AC is congruent to QS, and then AB is going to be congruent to QR. So I'm going to use 2 marks on this one because I already used 1 on the other one. And then angle B is congruent to angle R. Okay, so if we look at this one again, it's not side angle side because the angle is not included between the two sides. So this is our donkey postulate again, a money sign, which again, we can't use that one. So are the triangles congruent? We're going to say no. Actually, they could be congruent, but we don't have enough information to prove it unless we had a right angle, which we don't, okay? So, no, they're not. All right, number 20, given that W's X and YZ are parallel, that's what those two lines are. That's what these triangles are talking about here as well. And WX is congruent to Z or YZ. So those are these markings here, so no big deal. First thing we have is angle WXZ. So WXZ, which is this angle right here, is congruent to YZW, which is this angle right here. How do I know those two angles are congruent? What is our justification for that? Remember what kind of angles those are? So if we have our parallel lines, I'll draw a diagram we're probably more familiar with, and then have angles here and here. What kind of angles are those? Well, they're on the alternate side of the transversal and the interior of the parallel line. So these are alternate interior angles, which are, sure enough, congruent to each other. So these two are going to be congruent by alternate interior angles. You can just write AIA. Then we have XZ is congruent to XZ. Things are congruent to themselves. The reasoning behind that is the reflexive property. And then lastly, they said that the triangles are congruent. What postulate are we using? Well, we've got side, included angle, side, the same side, the same included angle, and the same side. So SAS. So side angle side, triangle congruency postulate. You can just write side angle side, it's fine. 21. M is the midpoint of HS and GT. Well, if M is the midpoint, that means that it cuts it it cuts it in half, right? Cuts both of them into equal halves. So GM is going to be congruent to TM, just as HM, Hannah, Montana, and Mississippi are going to be congruent to each other as well. And the reason for those is by the definition of what it means to be a midpoint. So if it's a midpoint, cuts them into 2 congruent halves, right? So definition of midpoint for both of those. Then they're telling us that angle GMH, so GMH, this angle right here, is congruent to the other angle TMS. And that's because those two are vertical angles, right? So don't forget vertical angles. We use that one all the time. Also, the alternate interior with parallel lines is used quite a bit too. All right, then they're saying the triangles are congruent to each other. What postulate did we use? Well, it looks like they gave us a side, an included angle, and another side. The same side, the same included angle, and the same side. So SAS, where the angle is included in between two sides. So SAS. All right, 2 triangles are both equilateral, which means all 3 sides are the same. Your friend says it means that they have to be congruent by the side postulate. Well, it is true that all 3 sides here, like 4, 4, and 4, are going to be congruent. But over here, if I have another equilateral triangle, it might be 8, 8, and 8. So even though they are all 3 to themselves going to be congruent, right? They're not congruent across. So these are going to be what we'd say they're similar triangles, but they're not necessarily the same size. So they're not congruent. They have the same shape, That comes from the angles, by the way. They would have the same 60-degree angles, but they're not necessarily the same size, because equilateral triangles are allowed to be bigger or smaller and still be equilateral. So we know they have the same shape, so we would say they're actually similar to each other, but not necessarily congruent because they don't necessarily have the same size, because their side lengths are not necessarily going to be the same across both triangles. All right, kind of a fun problem. What additional information do you need to prove the triangle is congruent by either side, 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 or side angle side? So on number 24, they want us to use side angle side. So the key on this one is we have to use an angle that's included in between the two given sides. Okay, so looking at the diagram we have here, the first thing that I notice is that AC is congruent to itself, right? Reflexive property. You can go ahead and mark that one. That one's actually pretty much given, just like vertical angles, you can mark it right off the bat. Okay, so always look for the reflexive property. AC is congruent to itself. So we have this side for both triangles. We have the right angles for both triangles. And so we have a side and an angle. The only thing we need now to prove it with side angle side is we need the side that's on the other side of the angle. So we have our side, we have our angle, and I need the missing side that's on the other side of the angle. So that's going to be the side BC has to be congruent to CD. So the missing information we need is that BC has to be congruent to CD. Okay, and if we have that, then we can prove that these two triangles are congruent by side angle side. All right, 28, we want to use side angle side again, right? So the angles that we have here that we know are going to be congruent are the vertical angles in the middle. Now that's just given to us. So we have our side and our angle. We need to know the sides that are on the other side of the angle. So that would be YV has to be congruent to VX. Then we can do side included angle side, side included angle side, where it's the same sides, the same angle, and the same sides. Okay, so we need to know that YV is congruent to VX. And if we know that, then we're good to go. All right, that's it. 17 minutes, pretty short. Let me know if you guys have any questions. I'm going to be out of cell service and Wi-Fi, believe it or not, in South Oklahoma for at least a few days. I'll definitely be coming back into the city right around probably Wednesday, or maybe sooner, right around Thanksgiving, so I can give you guys some help over the break if you need help. We can even do Google Meets for tutoring or whatever you guys need. So just please try to get caught up on your homework, submit all that stuff in. I will update grades again once you guys turn in some homework, and whenever you've completed the test for transformations, I'll put those grades in there as well. Okay, so please let me know if you need anything. We really only have, after today, three more lessons before we'll be done with congruency, and we'll take another test. If we are able, hopefully we'll be able to come back in person. This last week was really, really sad, kind of borderline depressing for me, because I know what it's like to have students in the classroom and how much I love my job, and then just not having you guys in class, man, it makes it really, really hard to find the motivation to do all this. So anyway, miss you guys. Hopefully we can be back in the classroom, but I don't have very high hopes, unfortunately. So I'll see you guys later. Let me know if you need anything, okay?